All right, so I get this graph here and I want to be looking for some kind of like hill or valley situation. So looking at my graph here, I can see that this here is kind of going down and then starts going back up. So this section here is going to be a local minimum, right? And then over here I'm going up, 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 but then I stop going up and go back down. So this must be a local maximum, okay? Your calculator, we can estimate those, but your calculator has a really good way of finding those, okay? I'm also going to point out, because I wasn't clear about that before, your local maximum value, the actual maximum value or the actual minimum value is a y value, it's a height, okay? Sometimes you'll be asked, where is the minimum located? And then it's asking for an x. But if it's saying, what is the minimum? It's asking for the y value. So here's how you do this, okay? I'm gonna write out the calculator steps and then we're gonna do it. So on the calculator, you are going to, once you have your graph, you're going to do second calc. Okay, so you're gonna go to second calc. And then see how it says minimum or maximum? That's what we want. So we want 3 or 4, right? Minimum or maximum. Okay, so we're gonna do the minimum first. So let's go to minimum. Then it's gonna ask me left bound. What that means is, see this little blinky guy? I just want that guy to be to the left of where I think the minimum is, right? So just to be safe, I'm gonna go press this button, okay? The left button, a little bit more, so it's definitely on the left-hand side, and I press enter. Okay, here, there we go. Okay, so I press enter. And then it says right bound. So now I'm gonna go to the right, move my little blinky guy to the right, and I'm gonna press enter. And then it says guess, so I wanna move my little blinky guy close to the minimum. It's called a cursor, but I like blinky guy better. And press enter. And it tells me that my minimum, there you go, x equals -3, y equals -2. And again, I want my y value. So I have a minimum at y equals -2. Okay, so my minimum value is -2. Now let's do that same thing with the max. So same calculator steps, I'm gonna do second calc. This time I wanna look for my maximum. Now I wanna use this arrow right here to go all the way over until my blinky guy appears on this side, right? I still wanna stay to the left because it's asking for the left bound, so I'm gonna just be somewhere on the left side of this right here, right? So imagine like drawing a line. I want my blinky guy or my cursor to be the left. Press enter. Then I'm gonna go over to the right. Press enter because it asked me for a right bound. And then I want a guess somewhere close to my maximum. And it's thinking, and I get maximum is at x equals 3, y equals 2. So I have a maximum at y equals 2. And those are my only ones. Remember with local, I could have multiple, but I don't in this case. Those are my only hill and valley type looking things. So I am finished. Moving on, whoops, to example 2. Notice example 2 does not say calc, so you are not allowed to use a calculator or Desmos or anything for this one. You have to know what shape this is. So my absolute value is always the same shape. We have a parent function for that. And that looks like, maybe you know what it looks like, know what it looks like, see if you're correct. It looks like, oh, wrong marker, see if you know what it looks like, beat me to it. Haha, like this, okay? So it looks like this V shape here, right? It's always gonna be positive. If you're not sure of what it looks like, plug in points, right? Plug in the absolute value of 2 is 2. The absolute value of -2 is also 2. Absolute value of 0 is 0, right? So you can plug in points there. Now I'm looking for a local maximum or minimum. This one does have kind of a valley looking shape here. It's okay that it's pointy. So this right here would be my minimum, okay? It is my local minimum. And actually, because I don't have any other ones, it's also my absolute minimum, okay? And that minimum is that we want to think about the height that it's located at. That minimum would be a big fat 0, right? The height is 0, okay? A little review for you. Is this differentiable? Right there. No, it's not because it is a cusp, right? Little review for you there. Okay, that is number 2. Questions on number 2? write them in your survey or your quiz that you're gonna take, because I can't answer your questions right now because I'm at home on my couch, as are you. All right, number 3, calculator again. So one more time, I'm gonna take my calculator. I'm gonna follow those same steps. So see if you remember those same steps. We need to go to y equals, and then, really quick, have to do this really first. Good thing I checked. Whenever we have trig involved, right? I know that it's trig because I've got this sign here. Whenever I have trig involved, I want to be in mode radian. So make sure that your calculator is in the right mode. Okay, now I can do second quit, go back here, and I'm going to put in x plus, I'm going to put 3/2 in parentheses, sine of x, close my parentheses, and press graph. Okay, this one, notice, does have an interval. Okay, so my calculator is already set there, but if it wasn't, you would go to window and you want your x min to be -10 and your max. Remember, these are both x's. Okay, for your intervals are always x's, so you want from -10 to 10. So I already have that, so that's not an issue. Now, oh my goodness, I have so many, right? So I want to look for minimums. Let's just do minimums first. It doesn't matter which order you do them in. So automatically I see that there's a minimum right here. Let me put it with my pen so you can see it better. So right here, right? It was up and then it goes down and then it starts going back up. So this right here is gonna be a local minimum. So second calc, minimum. I want my blinky guy to be all the way over here. He's moving, he's kind of slow. Go, 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 go. Okay. Almost there, almost there. Getting to the left. All right, left bound, enter. It's kind of hard to see. He's behind the X. See him there? It's like I Spy. All right, and then moving this way. If you are not my student and I'm watching this, you're watching this, I'm so sorry because you're like, who is this crazy chick that's teaching calculus? Okay, there you go. And minimum, haha. We want the Y value, remember, right? So you have a minimum is at Y equals, in AP Calculus, we use 3 decimals, so -9.702, right? Rounding up, because it's 1/7. Now, we've got some other ones, so let's keep calculating. Minimum. This will be a maximum, but I'm on the minimum train right now, so I'm going to keep going with minimums. So I'm going to keep going here. All right. To the left, right? It's asking for the left bound. It's to the left, so I press enter. Then I go to the right. I'm enough to the right, enter. I'm guessing it's around here, and I am getting, there you go. I want the Y value, so -3.41, rounding up to 9. 419. And I have one more minimum right here, this little valley dip guy thing happening. Oh, sorry, what did I press? I forgot to press second calc. Haha. Second calc, minimum. Left, technically I am to the left, I'm just gonna get a little closer. Right, wait, that's my maximum. I want my minimum. Minimum. And minimum. And guess. And I get 2.865, rounding up. 2.865. Whew, all right. And now let's do maximums. Second calc, if you're getting bored. I am too. Sorry about that. We're just gonna keep going. Feel free to fast forward if you understand this process. Now we're looking for the maximums. It's the same thing. I'm moving back to this first hill over here. Right here, trying to get to the left of it for my left bound. There you go. Now I'm moving to the right for my right bound. Then I'm moving to guess, and I get, so I have a maximum at Y equals negative, why is it not focusing? -2.865. Sorry that didn't focus there. Come on, iPhone. And then you got it again, second calc, maximum. Moving over here. Still going, still going. There we go, left bound. And I want to be to the right. Okay, it really doesn't matter how close you get with your left and right. You just want to make sure that it's close enough to your actual place. Because if I put like left bound over here, it might accidentally think we're talking about this maximum. So you just want to get close enough that it's clear which maximum you're telling your calculator to calculate. And I guessed maximum's at 3.419. And got one last, oh, man, second calc. Forgot it again. Second calc maximum. Move it over. All right, left bound. And right bound. And guess 9.702. All right. Now, there you go. So those are all of our locals. Now, if we were asked for the global, which we're not in this case, we're just asked for local, but just as a little review from yesterday, our global would be global maximum would be the very highest. So that would be this one here. So this one was our global, right? Or we could tell from just looking at the paper because these are our Y values, right? This is the highest, so that's our global. And then same, for minimum global, we want our lowest. So this one would be the global or the absolute. All right, the problem didn't ask us to do that, but just a little good review for you. All right. Last thing, you might be thinking, but wait, Miss Riz, you missed a minimum because you've got this little dip right here, right? Or you missed a maximum because you missed this little dip right here. Remember, we want it to be inside the interval. Oh, sorry. We want it to be in the open interval, right? Not at an endpoint. So a local cannot be on an endpoint. A global can. Okay, so local can't be on an endpoint. It's got to be inside the interval. It's got to be in your graph here. Your absolute can most definitely be at an endpoint. All right? All right, tune in next time for Note Card 33. Get excited. Go take that quiz and make sure that your notes are complete. And I will see you all in class mañana.